So let's talk about industrial illumination. We don't talk about it very often, except for places like this, and costs of getting it wrong. At an average mine site, for your company it could be slightly different, but ultimately it's all the same. We look at certain challenges, so we look at upholding operational safety. It's really important for our site to look very safe and proactive about safety. To maintain shift productivity, it's very important that every shift is as productive as the next one and even more productive than the previous one. It's important to maximize utilization of equipment, so I want my equipment up and running at all times and be available. Increased machine availability, same thing, so I want my machines running at optimal capacity. We want to reduce the operator fatigue. I don't want my people to be tired, I want them to be alert and active and snappy at all times and to be at full capacity. I want to avoid negative publicity. No one wants to be in the papers the next day for an accident or something like that. And you want to be seen as an industry leader. You want to be known as a company that looks after the new technology, that pushes the boundaries of safety and productivity and reliability and so on. But there's 24 hours in a day, and half of the days are usually nighttime. And people are not built to work at night. They were built to work in the day, we work in the day, and we sleep at night. So lighting is ultimately actually incredibly important. So this is what happens. Let's look at these values again when lighting was not involved. So we'll look at upholding operational safety. Trucks will run over, people get hurt. Near misses are very dangerous. So when this happens, mine usually shuts down for a number of hours, or it could be a number of days, it could be a number of weeks, depending on the severity of it. This is the reversing accidents, when pieces of machines reverse into each other. Again, it wasn't bright enough, they didn't see each other. There could be other reasons, but this could be a very big contributing reason. Maintain shift productivity. You want your equipment available. Remember we talked about it? This is accidents with two pieces of equipment. So each equipment, this is a $10 million excavator and a $5 million truck. Offline, could be weeks, could be days, depending on the severity of this. This is one of the most interesting one. This is a bucket wheel excavator that scooped up a dozer on the stockpile. How long do you think it would take to clean that up? How long do you think it would take to get that out and investigate? So the downtime is incredible. So you want to maximize utilization of equipment. You want your equipment ready to go at any time. This is the truck that reversed a little bit too far. That takes, again, you've got 3 pieces of equipment now involved in digging it out. This is not a photo of trucks sleeping. This is what happens when the operators run off the side of the wall because they were too tired at night and not alert enough to be doing what they're meant to be doing. It's not easy to flip a dozer, but that happens and it causes a lot of injuries, a lot of damage, a lot of downtime. This is one way to turn a $5 million truck into 4 sets of spare tires. That's a $5 million truck that's run into the high wall, into the wall, because again, an operator missed the T intersection. I actually did this presentation in Indonesia, and this is from the Indonesian company, and they were not happy about me having these photos. Actually, and this brings me to my next point, you want to avoid negative publicity. I got these photos from the internet. Actually, there's a Facebook site called Mining Mayhem. Fantastic sites to flip through, you see some wonderful accidents in there. So you don't want these kind of photos from your site leaking all over the web and becoming popular. You want to be seen as an industry leader. Remember how we talked about technology? We want to be, you don't want to have that kind of impression. So let's talk about this. So who's responsible for lighting on site? And I know I brought that up last year, but I can see that a lot of you were not here last year, and I think this is again very relevant to talk about. Ultimately, not many people. There's actually no direct responsibility for lighting usually. There's people responsible for electrical maintenance, there's people responsible for all sorts of things, but lighting is kind of one of those things that was installed originally, and as long as it's relatively maintained, as long as no one complains, things just go untouched and they can lead to big issues. So let's talk about how good is good and how much is enough. And again, I did it last year, but this year we're just going to touch on it and go deeper into it. It's not an ambiguous thing. Lighting standards not define, oh, this is bright, this is not bright enough. It's actually pretty straightforward. There's Australian standards that define the light levels you need to get. So if you don't get the light levels on a certain surface, you're basically not deemed to be operating at safe levels. So there's 3 Australian standards that are relevant. AS 1158, That's covering lighting for roads and public spaces. 1680 is probably one of the most relevant to all of us. This is a standard that covers workplace lighting in interiors. And 2293, so the first two standards are actually not mandatory, they're just the regulations. This is a recommendation from the committee that says this is what we think is a safe light level, and you better stick to it, because if something happens and you didn't, that's when you get slapped. 2293 is actually the only standard that is very mandatory, so if you don't comply with that, you will get shut down, because this is emergency escape lighting. In case of fire or emergency, this is a very dedicated set of lights that needs to come on and look for safety. That is mandatory. So that's usually, I find people stress a lot more about this one than the previous ones. This one does not cause downtime. The other ones do. So functional lighting. Let's actually look quickly at what the good lights are. What constitutes a good light. We look at CRI, it's color rendering index. How well you can tell colors under this light. The color CCT, color temperature of the light, daylight, and middle of the afternoon, you get a daylight. People usually tend to function a lot better in the daylight than in the evening. And the candlelight, this actually has to do with color temperature. Non-stroboscopic effect, we'll actually cover it a little bit later. Resistance to vibration and impact, resistance to ingress and water and dust, controlled glare, lighting pollutions, low EMI, and long life. And this is what I'm covering in detail. So resistance to vibration, you actually, when you're purchasing a light fitting, you really want to make sure that this light fitting is built for the job and it will actually do the job. Because there's no point purchasing something that's going to fail in the next 3 months and you have to do it again, and it basically defeats the whole purpose. So you need to make sure that you're buying a light fitting that's made for the job. So in this particular case, this is a bulldozer. These things are ridiculous vibration levels and everything snaps on them. So these lights need to be built for it. Color rendering index, how good you can tell colors under it. So you can see that this is before and after. No, I'm kidding, this is actually two different car parks, but this is the ability of you differentiating, being able to tell the colors under one light or the other. So the picture at the top features the low color rendering index, so your reds and yellows are really good colors that stand out. The blues and blacks are really hard to determine, whereas the picture on the bottom has a higher color rendering index. For some applications it's really critical, for some applications it's less critical, but you really need to do the job. The color temperature, this is what we were talking about earlier. So you function better in the daylight, people function psychologically better in the middle of the afternoon. So you really want to pick, whenever you can, you really want to pick the light that's closer to the afternoon sun, because that gives us a nice and productive feeling, because if you pick something that's really warm white, people are going to go to sleep. One good example of that, in McDonald's, they have really cool color temperature lights because they want you to have your burger and get out. In a very expensive French restaurant, they'll pick a warm light because they want you to stick around, have another bottle of water, have another dessert. They don't want you to go, they want you to be relaxed. So this is, has to do with color temperature. It's not rocket science. Stroboscopic effect, if you have conveyors or moving parts or something that's moving, especially moving really fast, you want lights that don't produce flicker, because that flicker can actually lie about the motion of the machine. It actually misrepresented. So sometimes it could appear moving backwards, it could appear moving at different speeds. You really want light that don't flicker. Resistance to impact. There's no point putting a fragile light in an application where it's going to get smashed by a rock. So you really want to make sure that you pick the right IK rating. All these things are usually in the specifications. IP rating, you want to make sure that it's protected from water ingress and dust. Resistance to corrosion. This is a lighting that's installed in the salt mine. We replace this every 3 to 4 months. So you have to pick the light that's built for it. Glare, this is actually a very interesting point, and I really want to stress on this one. This is how we, the common people, perceive the light, and we find this a lot. People go, we ask them, how'd you go with the light? They go, this is really bright. And by bright, they actually mean it's glary. So glare is the negative, it's a side effect. You really don't want the glare. So there's two types of glare. There's discomfort glare, and that's basically when you have to squint. And disability glare, that's when you can't even look at it, you have to block it from your voice. So discomfort glare is tolerated on industrial sites because, let's face it, we're not perfect. And the primary objective is operation, but disability glare is definitely not allowed because that's impacting people's operation. Another thing you have to look at is lighting pollution. You've probably seen, if you're away from the city and you're looking back, there's like a yellow hanging below. That's actually a negative thing about light. That's lighting pollution. You're trying to avoid that because that disturbs natural life, animals, nocturnal animals, and also that severely impacts astronomical observatories. And so you really try to minimize that whenever you can. Energy efficiency and fuel economy, something happened to my picture here, but that's probably because it's not even that important. In many cases, we're talking about power generation here, right? So we make our own power. Who cares about energy efficiency? Many companies fall in the wrong trap. They're trying to pick the light that's the most, the least amount of power. You need to focus on the application. You need to focus on the light levels you're going to get. The energy efficiency is good when you get it. If you don't get it, as long as you get the light levels, that's what's important. So don't fall in this trap. And ultimately, when we're talking about 20 watt light or 24 watt light, it's 4 watts, who cares? Move on. Ultimately, if you don't get the light level, someone's going to get hurt. That's important. Electromagnetic interference, I did talk about this 2 years ago, and I know there's a lot of people here from 2 years, so I'm not going to dwell on this, but a lot of cheaper lights are not built for it, and they will actually cause interference with radio communication. That can cause a lot more issues than what it's worth. For example, this is a quote that we hear on site. Still, unfortunately, even after years of me pitching this and us pitching this to the company, ever since we installed these bloody LEDs, we have to stop and turn the lights off to use our two-way radio. That's shocking. It should never happen. I can explain to you if you want, but this is not the point of the presentation. If it's a bad light, it creates bad background noise, it elevates the noise floor, and it can kill communication if it's not strong enough signal. Long life. So really, ultimately, a lot of companies are changing to LEDs because they get a long life. So if you tie all these factors together and you get a product that lasts through the life, we can actually, and this is the point that I wanted to bring across, you can actually change the perspective, the way we see the light. We used to see light as consumable. So we see the light and we think it's a light bulb, we're going to have to change it in the next 2 years, so I'll pick the cheapest light. You'll pick the light that's going to be the most cost effective down the track. But if you're picking the light that's going to last 50,000 hours, that's like 6 years, 24-hour operation, that's as long as the life of that machine. So you're no longer picking a consumable, you're actually picking a part of that machine. So if it's a $10 million excavator, the $100 that you saved on the light bulb are irrelevant. What's relevant is how often that machine is up and running and generating money. And the last point that's the most obvious to all of us, it's always tempted. There's always someone willing to do it cheaper. I think this is a very self-explanatory example. Again, you really need to look at the real life application. What is the impact of you making that decision? Imagine we're talking about the operators, they drive little trucks, right? You have a $5 million truck driving down, and that's what puzzles me. You have a $5 million truck driving in the circuit all night long, and you hire the best people, you pay them a lot of money to drive these trucks, to drive them efficiently, to drive them gently, and not to rip it. You wouldn't hire a blind driver, right? You do the tests and all these due diligence tests before you hire these people, but you will jeopardize the lighting system and essentially render these good drivers blind by not having a good lighting system on. And the cost of actually putting a good lighting system are very negligible in comparison. So these are 4 steps of classic responsibility defense. This is actually a legal terminology, but this is how most of us actually think. So at first we just go, oh, this is not a real risk. It's probably not concerns me so much. It's not a real thing. The second step, it's like, oh, it's actually a real risk, but it won't happen to us. This is the second step of that. The third step is, it's a real risk and it has happened to us, but no one got hurt. Usually this is the near misses. The accidents that don't even get reported. And the fourth and final stage, it's a real risk and it has happened to us and people did get hurt, but it's not our responsibility. Because it's no one's responsibility to maintain the light. It's kind of like an engineers will put it up and then this whole thing just gets maintained. So what I wanted to say is that it's actually really, really important to stop and think, because it's our colleagues that are out there working at night. The majority of people here are management. Management doesn't even come to the mine sites at night. They can work during the day, so you don't know, they don't know, until somebody reports it, and people might not report it because they don't want to be seen as a whinger. You could actually have a dangerous situation on the site. And speaking of financial, we understand we're not doing this the first time. We've been doing this for years, and we understand there's tough economic times and there's no money anywhere. But if it's done right and if it's done properly, there's actually no cost implications. We can usually justify the right application, the right light for the right application. In some instances, we can save millions of dollars just with converting it. So if you actually stop the traditional way of thinking it and put it in a new model, it works. And we don't sell the cheapest lights, but it works. And if it didn't work, people wouldn't have bought it. High base, you can justify high base, you can justify conveyor lights because there's thousands of lights. And the more lights, the better, the easier it is to justify. And machinery, we talked about the millions of dollars. And for example, in this case, it's $20,000 investment on a $10 million machine. So that's really easy to pay back. And from the investment point of view, this was actually done for financial people, for the bean counters in the office. We presented in Canada at one of the financial conferences that this went off. If you can, it actually makes $576,000 over 7 years, and on a $19,000 investment. So if you actually convert it from a financial point of view, like a return on your investment, that's 544% return every year, annually, on your money. If this is not the best investment, then I don't know what it is. So yeah, it's just about thinking. It's just about the application. Keep the application in mind, and keep the safety of your colleagues in mind at the forefront.